Hello. So this is a video for one of my buddies in chem who doesn't um have a grasp on ionic and covalent bonds right now. So I'm making a video to explain this to them. And maybe this could help other people too. I don't know. But basically I'm going to be explaining ionic bonds and then in this video, and then I'm going to explain covalent in the next one. But I guess I should start out with what ionic bonds are. Ionic bonds are bonds with non-metal and metal atoms. So what that would be, for example, I have a periodic table pulled up. Anything with the word metal in it is usually a metal, unless it says non-metals. It's obviously not a metal. Anything that includes the word metal that doesn't say non in front of it is a metal. So, of course, this is a non-metal plus metal bond. So let's take a metal. Let's just do gold. Everyone knows gold. So Au is gold, right? Charges do matter. So I should probably know the charge of gold. It's a range, but I guess +1. So here's gold, right? We have gold. And then let's pick a non-metal. Let's do boron. Boron is a metal, isn't it? No. Of course it's not. What am I talking about? Okay, boron. And then boron has a charge of +3. So, wait. Okay, hold on. Scratch the boron because that has a positive charge. You'd probably never see that. It should have a negative charge. Let's do fluorine. It has a charge of -3. So, we have these two now. So now that we have these two, we have to bond them. And the way that we're going to bond them is, obviously, if you were to bond them in science, it would, like, bond. But, let me explain this. Now that we have these two, gold has a charge of +1, and fluorine has a charge of -3. Now, we want the overall charge to be 0. So, OC, standing for overall charge, we want that to be 0. And the way that we're going to achieve that is we're going to add these two together, right? So if I were to add a +1 to a -3, you would get a -2. But that's not 0. So the way that we're going to do this is either you could be impractical, I guess, and have 3 golds, which is a lot harder to do, or we could have, well, no, that's very practical. What am I talking about? Okay, sorry for all the mistakes in this. I have no script. I'm just talking about this as I go. So we're gonna take this, the charge of gold, right? We're gonna put this over here, right? Stay with me now. And then we're gonna take fluorines, and we're gonna put that over here. And now that we do that, it's gonna be Au3, right? And then I should probably put this in brackets. I'm pretty sure this is a polyatomic. So with polyatomics, if I were to do a bond with a polyatomic, I would have to put brackets around it. But from what I'm seeing, it's not a polyatomic. No, so it's not a polyatomic. So I don't need to put brackets around this. But if it was a polyatomic, you just put brackets around it and then the number at the bottom. So now we have gold, and now we have fluorine. And fluorine only has 1, so you don't need to put the 1. I mean, you can put the 1 if you want, but it's not necessary. And that is how you would write the bond for this ionic bond, which is gold and fluorine. So for my buddy in chem, if you ever see this on the test, that is what our teacher would probably be asking for if she said to name the bond. So now that we know, now that like we've had some practice with it, I'm also going to show you how to do the Lewis dot structures. I'm pretty sure you already know how to do this, but it's just helpful to know. So let's do a Lewis dot structure for, let's do sodium chloride. That's a very common one that's shown up on tests. So we've had this on tests before, and the way that we're going to do the Lewis dot structure for this is sodium has 1 valence electron, and chlorine has 7. So this is perfect because then they're both gonna get as many as they want. So 1, 2, 3, 4, 5, 6, 7. There's one little lone valence electron here, but don't worry, we got sodium to share a electron with chlorine. So now chlorine has 2, 4, 6, 8. This represents 2, and sodium now has 2, so it's happy. Yay! And that's how you draw a Lewis dot structure for a ionic bond. So that's basically like pretty good explanation of ionic bonds. If she asks for the name, let's say again that we have sodium chloride, the way that you would name an ionic bond is first you look at the cation, which is the positive charged ion, which is in this case sodium. Yay, positive. So the way you can remember this is cat ions are positive, right? I know, terrible pun. Positive. It's a terrible pun, but it's a great way to remember it. And then we have a cat ion, and then we have an anion, which is the negatively charged ion. You're never going to have two positives. That's why when I was explaining the other one earlier, that would never happen. So you're going to have a positive ion, which is the cation, and a negative ion, which is, in this case, our chloride with -3. So the way you're going to name it is first you're going to name the cation, which is our positive ion, which is in this case is sodium. So we're going to write down sodium. And then we're going to name the anion. But with this, we are going to put an IDE ending, unless it is a polyatomic. If it is a polyatomic, we don't need to add the IDE ending. But since that chloride is not a polyatomic, for my buddy who's watching this, we have a packet that says all the polyatomics, you know that, and we've been memorizing them. So you can look at that for references. But we're going to add an IDE ending on chlorides, and it's not an polyatomic ion, or chlorine, so now it will be chloride with our IDE ending instead of INE. So INE changed to IDE, and that is how you would name a ionic one, like an ionic bond, sorry. So sodium chloride is an ionic bond, of course. So that's how you would name them. I guess that's all I have to say. I guess let me explain polyatomics real quick because that would be helpful for you. Let me pull up a polyatomic list. Sorry I have to keep pulling up stuff. I just don't know all this off memory. Okay, so sulfate has a charge of -2, so they're gonna pick a little positive guy. Let's do no, let's do phosphate. Phosphate has a charge of -3, so let's get a +3. Any of these that aren't metal. So boron, phosphate. Let's do that, guys. So we got boron, and then we're gonna have phosphate, which is PO. It has a charge of -3, but the sign is PO4. Boron has a charge of +3, and you have a charge of -3. So in this case, we don't need to put anything in brackets. So this would just be BPO4. And that's how you do that for boron phosphate. Let's try to get a different one with less of a charge so I could show you how to do that. Okay, sulfate. SO4 is sulfate, and it has a charge of -2, which is great. You have +3, correct, and then sulfate has -2. Right. So if I were to write out a bond between these two, obviously +3 and -2 do not equal 0. And we need that to equal 0. So again, we're going to do our little swap. We're going to take this, put this down here, take this, put this down here. And now we're going to have boron 2, right, because there's 2 borons. And since sulfate is a polyatomic, how fun. We're going to put sulfate in brackets, SO4, and bracket 2. And that is how you would show that on a test or any of the which, if you get asked to name an ionic bond that has a polyatomic, that is how you would write it out. I guess that's all I have to say for this. I hope this was helpful in any way to you. If you have any questions, just like let me know, and I could make another video or something like that answering the any questions you might have. But yeah, I hope this was helpful in any form, and have an awesome day. Yeah, if you have any questions, let me know. And that's all for a little chemistry video. Bye!